Okay, let's start. Hello, my name is Vladik Khononov, and when I was 9 years old, I had this crazy dream of writing my own computer games, and so I've learned to code. As you might imagine, since then I didn't write any games whatsoever, but somehow for the last 18 years I ended up playing the game of battling the complexities of enterprise software. Currently I serve as the chief architect for a company called Internovus. And the peculiar thing about Internovus is that we've been using domain-driven design since the first day our company was founded. And I'm here today to share with you our DDD journey. I divided this presentation into two parts. In the first one, I'll walk you through the various systems from our domain and how we've implemented them. Now, of course, I won't be able to cover everything we've done, so therefore I will concentrate on 5 Bonnet contexts that demonstrate the different approaches to DDD that we've tried and the results that we've achieved. In the second part, I will use those 5 stories to share some practical advice on domain-driven design, domain modeling, CQRS, event sourcing, microservices, all based on our experience at Internovus. So without further ado, about 7 years ago, I've got a phone call from a friend. He said that he was starting a new company. The business was not going to be simple, but if I joined him, technically, I could do whatever I wanted. And since back then I had a pretty boring job, I've agreed just like that. Let me show you what I've got myself into. Say you're producing a product or a service. Internovus allows you to outsource all your marketing-related chores. We'll come up with the best marketing strategy for your product. Our copywriters and graphic designers will produce tons of creative materials, such as banners and landing pages, that will be used to run campaigns to promote your product. All the leads generated by these campaigns are going to be handled by our own sales agents who will make the calls and sell your products. And most importantly, this whole process provides many opportunities for optimization. And that's exactly what our analysis department is doing. They're going to analyze all this data to make sure that our clients are getting the biggest bang for their buck, be it by pinpointing the most successful campaigns, most effective creatives, or by making sure that the agents are working on the most promising leads. That's the system that I signed up to build, and since we were a self-funded company, we had to get rolling as fast as possible. Therefore, we started by implementing the first third of our value chain. We had to provide a system for media buyers to manage contracts with various publishers, a catalog for our designers to manage their creatives, and of course, a campaign management solution to run advertising campaigns, which meant not only a management system, but an advertisement hosting and serving solution as well. Now, I don't know about you, but back then, these business domains sounded terribly complex to me. Fortunately, not long before we started working, I had read a book with its title promising to help to tackle such complexities. And of course, I'm talking about Eric Evans' seminal book, Domain-Driven Design, Tackling Complexity in the Heart of Software. Who read this book? And who read this book beyond the first chapter? 3 hands. Okay, to be honest, it's not an easy book to read. And luckily for me, like most of you, I felt that I've got a really strong grasp of domain-driven design just by reading the first 4 chapters. Guess how the system was initially designed? Its architectural style could be summarized as aggregates everywhere. Creative, agency, advertiser, publisher, funnel, placement, campaign, each and every noun in the requirements was proclaimed as an aggregate. And of course, all those so-called aggregates resided in a huge lone bounded context. Exactly the same monolith that everyone warns you about nowadays. And of course, those were no aggregates. They didn't provide any transactional boundaries, and they had very little behavior in them. Just a typical anemic domain model that only describes the data structures. All the behavior, on the other hand, was here, in this enormous service layer. Now, let's be honest, this design is no work of art. This is like by-the-book example of how you not do domain-driven design, right? However, things looked quite different from the business standpoint. From the business's point of view, this project was considered a huge success. Because despite this imperfect architecture, and despite our very unique approach to QA, we delivered working software in a very aggressive time to market. How did we do it? And the answer is ubiquitous language. We somehow managed to come up with a robust ubiquitous language. None of us had any prior experience in online marketing, but nevertheless, we could hold a conversation with domain experts. We understood them, they understood us, and to our astonishment, domain experts turned out to be really nice people. They really enjoyed and appreciated the fact that we are willing to learn from them and their experience. And this smooth communication allowed us to grasp the business domain very quickly and to implement its business logic. And yeah, it was a very big and scary monolith. But for two developers in a garage, it was just good enough. Again, working software in a very aggressive time to market. And this diagram sums up our understanding of domain-driven design at this stage. Ubiquitous language and anemic domain model in a monolithic bounded context. As time passed, leads started flowing in, and suddenly we were in a rush. Our sales agents wanted a robust CRM system, customer relations management system, to work with. The CRM had to aggregate all incoming leads, group them based on different parameters, distribute those leads across multiple sales desks around the globe, and it also had to integrate with our clients' internal systems, both to complement our leads with additional information and to notify the clients about changes in the leads' life cycles. And of course, the CRM had to provide as many optimization opportunities as possible. For example, we needed the ability to make sure that agents are working on the most promising leads, to assign leads to agents based on their past performance and qualifications, and to allow a very flexible solution for calculating agents' commissions. And since all of these requirements didn't quite fit any existing off-the-shelf products, we decided to roll out our own CRM system. And our initial implementation approach was the good old DDD Lite. We'll call every noun and aggregate and shoehorn them into this huge monolith. But this time, something felt wrong right from the start. We noticed that all too often, we were adding awkward prefixes to aggregates names, like CRM lead and marketing lead, marketing campaign and CRM campaign. And interestingly, we never used those prefixes in conversations with domain experts. Somehow they always understood the meaning from the context. And one day it dawned on me. There was a chapter with something about context in that big, scary book. So I went back, and this time I read the blue book cover to cover. I learned that bounded contexts solve exactly the same issue that we had experienced. They protect consistency of the ubiquitous language. Also by that time, von Vernon's book came out, Implementing Domain-Driven Design, and from it, I finally understood that aggregates aren't just data structures, but they play a much more important role by protecting the consistency of the data. So we took a few steps back and decided to redesign our initial CRM solution to reflect these revelations. First of all, we divided our monolith into two distinct bounded contexts, marketing and CRM. We didn't go with microservices here or anything like that. We just did the bare minimum we needed to protect our ubiquitous language. However, in this new bounded context, we were not going to repeat the same mistakes we did in the marketing context. No more anemic domain models. Here, we would implement a real domain model with real by-the-book aggregates. In particular, we promise that each transaction will affect only one instance of an aggregate. Instead of an ORM, the aggregate itself will define the transactional scope, and the service layer will go on a very strict diet. And all the business logic will be moved into the corresponding aggregates. Frankly, we were so enthusiastic about doing things the right way, finally, but soon enough it became apparent that modeling a proper domain model is damn hard. Relative to marketing context, everything took much more time. It was almost impossible to get the transactional boundaries right the first time. We had to evaluate at least a few models, test them out, play with them, only to figure out later that the one that we hadn't thought about before was the correct one. The price of doing things the right way was high, a lot of time. And sooner than later, it became obvious. No chance in hell we are going to meet the deadlines. And then our management decided to help us. They offloaded implementation of some of the requirements to DBAs. Yeah, store procedures. And this one decision did so much damage. Now, not because SQL is not the best language for describing the business logic, no. The real issue was a bit more subtle. This situation produced an implicit bounded context with its boundary dissecting one of our most complex business entities, the lead. The result was two teams working on the same business component, implementing closely related features, but with minimal interaction between them. And of course, there was no ubiquitous language between those teams. Literally, each team had its own vocabulary to describe the business domain and rules. The Conways Law kicked our asses big time. The models were inconsistent, there was no shared understanding, knowledge was duplicated here and there, and rest assured, when this business logic had to change, the implementations went out of sync just like that, a complete nightmare. Needless to say, the project wasn't delivered anywhere near on time and was full of bugs. Nasty production issues that had flown under the radar for years, corrupting our most precious asset, our data. The only solution for fixing this mess was to throw away the old implementation and to rewrite the lead aggregate from scratch, this time in the proper boundaries, which we did a couple of years later. Wasn't easy, but the mess was so bad there was no other way around it. And to sum it up, at this stage, our understanding of domain-driven design looked like this: ubiquitous language, protected by bounded contexts, and instead of an anemic domain model everywhere, a proper domain model everywhere. And of course, a crucial part of domain-driven design is missing here: subdomains, their types, and their effects on implementation strategies. Initially, we wanted to do the best job possible, but we wasted a lot of time and effort on building domain models for supporting subdomains. And as Eric Evans put it, not all of a large system will be well designed. And we had to learn it the hard way. And we wanted to use the acquired knowledge in our next project. After the CRM was rolled out, we've noticed there was an implicit domain spread across marketing and CRM. Whenever the process of handling incoming customer events was modified, we had to introduce changes both in marketing and CRM. And since conceptually this process didn't belong to any of them, we decided to extract this logic into its own dedicated bounded context. We called it event crunchers. And since we didn't make any money out of the way we move data around, and we couldn't use an off-the-shelf solution here, it looked pretty much like a vanilla supporting subdomain. And we designed it as such. Nothing fancy this time, just some simple ETL-like transaction scripts. And this solution worked great, but for a while. As our business evolved, we implemented more and more features right here. BI people asked us to put some flags, a flag to mark a new contact, to mark a new lead, to group them based on specific brands and other parameters, etc., and eventually those simple flags have evolved into real business logic with complex rules and invariants. Now, guess what happens when you implement complex business logic as a transaction script? You know what happens? This happens. What started out as an ETL script grew up to be a fully fledged core domain. And since we didn't adapt our implementation strategy, we ended up with a huge ball of mud. Each modification to this code base became more and more expensive, quality went downhill, and at some moment we were forced to rethink our implementation. We did it about a year later. By that time, the business logic grew so complex it could only be tackled with event sourcing, so we refactored this code into an event source domain model with other bounded contexts subscribing to its events. And we had a very similar experience in another project. One day, our sales desk's managers had asked us to automate a simple yet tedious procedure that until then they had been doing manually, calculating commissions for sales agents. And again, it started pretty simple. Once a month, just calculate a percentage of each agent's sales and send the payments reports to the managers. As before, we contemplated whether or not this was our core business domain. And the answer was no. We are not inventing anything new here. We are not making money out of this process. And if there was an option to buy an existing implementation, we definitely would. We definitely would. So not core, not generic, but a typical supporting subdomain. Therefore, again, we didn't go crazy over its design. Just some active record objects orchestrated by a big service layer. Once this process became automated, boy, did everyone become creative about it. Our analysts wanted to optimize the shit out of it. They wanted to try out different percentages, and they wanted to make them functions of sales prices, they wanted to unlock some additional commissions based on some business goals, etc. Guess when this implementation has broke down, and it did break down. Again, the code base became an unmanageable ball of mud. Adding new features turned out to be very expensive, bugs started to appear, and when you're dealing directly with money, even this tiniest bug can have some serious outcomes. Since I'm being recorded, you can ask me during the break why am I telling this. As with crunchers, at some point we couldn't bear it anymore. We had to completely throw away the old code and rewrite it from ground up. This time as an event-sourced domain model. But let's see what happened here. Just as in the case of event crunchers, the business logic was, the business domain, was initially categorized as a supporting one. But as the system evolved, it gradually mutated into a core business domain. We found ways of making money out of this process. However, there is a striking difference between these two bounded contexts. For the bonuses, we had a ubiquitous language. And even though the initial implementation was based on active records, we could still have a ubiquitous language. You know, CRUD is not a bad word if your domain experts are speaking about creating, reading, updating, and deleting. But as the complexity grew, the language got more and more complicated as well. At some point, it could no longer be modeled as active record objects. And this allowed us to notice the need for a change in the implementation strategy much earlier than the case of crunchers. So we saved a lot of time here by not trying to fit a square peg in a round hole thanks to the ubiquitous language. And that's what our vision of DDD looked like at this point. Pretty much a classic one: ubiquitous language, bounded contexts, different types of business domains, and implementation, which depends on the type of the business domain. And the fifth bounded context that I wanted to talk about is called Marketing Hub. Our management was looking for a profitable new vertical. They pondered, why couldn't we use our ability to generate massive amounts of leads and sell them to smaller clients, ones we didn't work with before? So they decided to give this idea a try. And as I said, this project was called Marketing Hub. And since this domain was defined as a new profit opportunity by the business, by the management, it was clearly a core business domain. Therefore, design-wise, here we pulled out the heavy artillery: event source domain model, CQRS, and back then one buzzword started gaining lots and lots of traction: microservices, so we decided to give it a try as well. That's what our solution looked like. Small services, each had its own database, both synchronous and asynchronous communication between them. On paper, it looked like a work of art. In practice, you are laughing for a reason, not so fast. We naively approached microservices thinking that the smaller the service, the better. So we drew service boundaries around the aggregates. In DDD lingo, each aggregate became a bounded context on its own. And again, initially it looked great. It allowed us to implement each service according to its specific needs. Only one would be using event sourcing, and the rest would be state-based aggregates. And all of them could be maintained and evolved independently. Heaven. However, as the system grew, the services became more and more chatty. Almost each of them needed data from all other services to complete some of its operation. The result, what was intended to be a decoupled system, ended up being a distributed monolith. An absolute nightmare to maintain. There was another issue we had with this architecture. We had used the most complex patterns for modeling the business logic: event sourcing and domain model. We carefully crafted all those services and interactions between them, but it all was in vain. Behind this complex architecture stood a very simple business logic. So simple, it could have been implemented using active records. Turned out that despite the fact that it was considered a core domain by the business, it had no technical complexity in it. The business people were looking to make money not by clever algorithms, but by leveraging our existing relationships with other companies. As a result, technical complexity was much higher than business complexity, and when these two differ greatly, we usually call it accidental complexity. And this architecture ended up being exactly that, accidental complexity. It was clearly over-engineered. So those are the 5 bounded contexts that I wanted to tell you about: marketing, CRM, crunchers, bonuses, and Marketing Hub. As I said in the beginning, we have more systems. That's not all, because based on these 5, it may sound like we're a bunch of losers who cannot do anything right. But I wanted to show you the bounded context that we learned from. So now Let's see what we've learned from this experience. First and foremost, the ubiquitous language. For me, ubiquitous language is the most important part of domain-driven design. This is the core domain of DDD. The ability to speak the same language with domain experts proved to be indispensable for us. It turned out to be a much more effective way to share knowledge than documents, tests, and even Jira. And more than that, the ability to hold a conversation with domain experts, for us, was a major predictor of project success, like in our marketing context. When we just started, our implementation was far from perfect. But the robust ubiquitous language compensated for the architectural shortcomings, and we were able to deliver the project's goals. In the CRM context, we screwed it up. Unintentionally, we had two languages describing the same business domain. This led to lots of problems, and even though we've strived to have a proper design, because of the communication issues, we ended up with a huge mess. In the event crunchers, this project started as a simple supporting subdomain, so we didn't invest in the ubiquitous language. But when the complexity started growing, we regretted this decision big time. Even though we had to redesign the project, it would have taken us much less time had we initially started with the ubiquitous language, like we did in the bonuses project. Here, the business logic became orders of magnitude more complex, but the ubiquitous language allowed us to notice the need for a change in the implementation strategy much, much earlier. And speaking of supporting subdomains, it doesn't really matter what kind of business domain you are working on, core, supporting, or even generic. Our take on it right now is that having a ubiquitous language is not optional for any of them. And we've also learned to invest in the ubiquitous language from early on. It is practically impossible to fix a language if it has been spoken for a while in a company, like in the case of our CRM system. We were able to fix the implementation here. Wasn't easy, but eventually we did it. But that's not the case for the language. To this very day, some people are still using the conflicting terms that were defined in the original implementation. Also, if you take care of the ubiquitous language early enough, it's very cheap. Many have the impression that it will be expensive to allocate domain experts' time for interaction with IT people. Not true, at least at our case. Our domain experts were, from their past experience, were sick and tired of software engineers trying to act as if they know better how to solve problems in business domains they have no clue in. And that's why they were so cooperative and willing to help. Next, let's talk about domain types. We all know that according to domain-driven design, there are three types of business domains. Core domains, the stuff that the company is doing differently from its competitors to gain competitive advantage. For example, in our case, it's the different way we are managing our campaigns, the different ways we are optimizing them, the different ways we mark most promising leads, the algorithm that matches leads to agents to maximize the chances of conversion. All the stuff that we had to implement itself because no one else is doing it in the same way. Supporting domains is all the stuff you do differently from others, but it doesn't provide any competitive edge. For example, in our case, in marketing, we had a creative catalog. So there was no existing solution for creative catalog, so we had to implement our own, but nothing special or complex about it. Graphic designers would just upload new files, edit them, delete them. Boring business domain. And finally, generic domains. Generic domains are the stuff that everyone is doing in the same way. Those are the solved solutions. Those are the well-known algorithms that everyone is using. For example, encryption algorithm, authentication algorithms, all the stuff that will be much more expensive and risky to invent yourself than to just use an existing solution. Now, it's a common practice to use this categorization to drive design decisions. For core domains, use the heavy artillery. Build a domain model with DDD's tactical patterns or event sourcing. Supporting domains can be implemented with some rapid application development framework because, frankly, most of them are very simple. There is no complex business logic in them. And generic domains, the solved problems, in many cases are cheaper and safer to buy or adopt than to implement yourself. However, this model didn't work well for us. The thing is, companies, and especially startups like ours, tend to change and to reinvent themselves over time. Businesses evolve, new profit sources are evaluated, others neglected, and sometimes unexpected opportunities are discovered. As a result, business domains types change accordingly. Speaking of our company, I think I have experienced almost all the possible combinations of such changes. For example, event crunchers and bonuses. Both started as supporting domains, but once we discovered ways of making money out of these processes, they became our core business domains. In the marketing context, we implemented our own creative catalog. Nothing really special or complex about it. However, a few years later, an open source project came out and it offered the same functionality and even more features than we originally had. So we threw out our implementation and replaced it with this product. A supporting domain became a generic one. In the CRM context, we had this algorithm that evaluated and identified the most promising leads. We refined it over time, tried various implementation, took it, hacked it, but eventually we replaced it with a fully managed machine learning model running on AWS. Technically wise, a core domain became a generic domain. We've also seen our marketing hub context. What started as a core domain ended up being a supporting domain, since the competitive edge here resided in a completely different dimension. And of course, we have quite a few examples in our industry of companies that turned generic domains into their core business. For example, Amazon and their AWS cloud. Now, once this kind of change happens, your design should evolve accordingly. Failing to do so in time will lead to lots of accidental complexities and pain, architectural pain. Therefore, instead of making design decisions based on domain types, we prefer to reverse this relationship. For each domain, we design its implementation strategy first. No gold plating here, the simplest design that will do the job. And from this design, we deduce the domain's type. The first benefit of this approach is less waste. Your implementation is driven by the requirements at hand. It's not going to be over-engineered as it happened for us in the marketing hub context. And it's not going to be under-engineered as it happened for us in the bonuses context. Second, reversing this relationship creates a dialogue between you and the business. And sometimes business people need us as much as we need them. Because if they think that something is a core business, but you can hack it in a day, then probably some questions should be raised about the viability of that business. On the other hand, what if a domain is considered as a supporting one by the business, but it can only be implemented with a domain model or event sourcing? And that's where things start to get interesting. There are two options. First, maybe the business people got a bit over creative with the requirements and ended up with accidental business complexity. It happens. In such case, the requirements can and probably should be simplified. Second, it might be that the business can employ this domain to gain an additional competitive edge, but they didn't realize it yet. as it happened with our bonuses module. In such a case, you're helping your business to identify new profit sources and opportunities much faster. Now, how do you choose this implementation strategy? At Internovus, we identified a couple of pretty simple heuristics that allow us to streamline this decision-making process. The most important decision you have to make here is how are you going to model the business logic in code. And here we have 4 options, 4 patterns. First, transaction script. Simple, straightforward procedural script. Absolutely nothing fancy, just make sure that each operation is transactional. Either it succeeds or fails. Second, active record. Same procedural code as transaction script, but instead of accessing the database directly, it operates on active record objects that abstract the persistence mechanism. In DDD lingo, this pattern is also known as an anemic domain model. Both those patterns were defined in Martin Fowler's book, Patterns of Enterprise Application Architecture. And another pattern from this book is domain model. And I will use it as an overarching term for domain-driven designs, technical patterns such as aggregates, value objects, repositories, etc. And finally, we have event source domain model. It is based on the same principles as domain model, but using event sourcing. Only events are used for representing changes in the aggregate's life cycles. Now, you can decide which of these patterns you should use by answering a few questions about your business domain. First, does domain in question deal with money directly, require deep analytics, or require an audit log by law? If the answer is yes, you need event-sourced domain model. Second, how complex is the business logic? Is it more complex than some input validations? Does it have complicated business rules and variants? If it does, use the domain model. Third, if on the other hand the business logic is simple, then how complex are the data structures? If you've got some complicated object trees with relationships between them, go with active record. And lastly, if the answers to all those questions were negative, use a simple transaction script. Now, once you've decided which of these patterns to use, it becomes a trivial job to map a suitable architectural pattern. In most cases, event sourcing requires CQRS. Domain model requires hexagonal architecture, use layered architecture for active records, and for transaction script, in many cases, you can even do away without layers. But there is one exception here, and that's CQRS. CQRS can be very useful not only for event sourcing, but for any of these patterns, but I will get back to it in a minute. Now, let's say you've chosen an implementation strategy, but over time, it started breaking under its own weight. For example, you've been using active records, but maintaining and modifying the business logic started to become painful. This pain is a very important signal. Use it. It means that the domain has evolved, and it very well might be that it's time to rethink its type and its implementation strategy. If the type has changed, talk with the domain experts to understand the business context. If you need to redesign the implementation to meet the new business realities, don't be afraid of such a change. Once this decision of how to model the business logic is made consciously, and you're aware of all the possible options, it becomes much, much easier to react to such a change and to refactor to a more elaborate pattern. Now let's talk a bit more in depth about CQRS. Historically, CQRS is closely related to event sourcing. If you're doing event sourcing, in almost all the cases, you need CQRS. But it's crucial to understand that event sourcing and CQRS are not the same. Instead, they are two conceptually different patterns. Event sourcing is a way of modeling a business domain. CQRS, on the other hand, is an architectural pattern. It allows you to represent the same data in different persistent models. For example, for event sourcing, you have the event store for writing data and projections for reading. Same data, but persisted in different models. We found that CQRS can be very beneficial for all kinds of business domains, even for those implemented as simple transaction scripts or active records. In such cases, you can do projections out of the persistent state. We call them state-based projections. And by using CQRS in this way, we've taken lots of complexities, for example, in the marketing context. Despite the fact that the vast majority of the business domains in this bounded context were implemented as active records. We used the relational model for reading, and we projected a model for searching data in Elasticsearch. And then we used some smart caching mechanism to project flat files that can be read straight from S3 service. Again, same data, but persisted in different models. Also, CQRS stands for command and query segregation, responsibility segregation. Don't be too dogmatic about this definition. There is no point in having your commands void. The system which executes a command, it should know the result, whether the command succeeded or it has failed. If it has failed, why it failed, what were the error messages, if validation fails, what exactly failed, how to notify the clients. Therefore, as Jimmy Bogart suggested yesterday at his talk, we also return data when executing commands, as long as this data comes from the database which is used for writing data, as long as it's strongly consistent. So, our commands can return data, but our queries cannot modify data. That's how we define CQRS for us. And finally, let's talk about bounded contexts. At Internovus, we've tried quite a few strategies for decomposing a system into bounded contexts. First, we tried linguistic boundaries. We split our initial monolith into marketing and CRM contexts to protect our ubiquitous language. Next, we've tried domain-based boundaries. And most of our business domains were implemented in their own bounded contexts, for example, crunchers and bonuses. We also tried dedicating a bounded context for a single aggregate. This approach had very limited success in the Marketing Hub project, but later on, we have extracted a lot of business entities out of the marketing monolith into dedicated bounded contexts, and in this project, this approach worked much, much better. And finally, I also shown you how we dissected an aggregate into two different bounded contexts. This strategy can be called suicidal boundaries. Don't ever try this at home, okay? If you take one thing out of this presentation, don't do it. That's it. But seriously, as this paper says, correct boundaries are important for peaceful coexistence of systems and teams in our case. So after trying out many ways of doing it, I want to show you the strategy for setting the boundaries that we are using right now. First of all, we have to understand that despite the fact that they have been used interchangeably lately, bounded contexts are not microservices. Each microservice is a bounded context, but not each bounded context is a microservice. The goal of bounded context is to protect the ubiquitous language by making sure that each term of the language has exactly one meaning, to make sure there are no conflicting models in the same bounded context, in the same system. For example, as I said previously, in our original design of the CRM system, we had terms with multiple meanings, lead and campaign. According to domain-driven design's principles, we split this model such that each term had only one meaning in each bounded context. Microservices, on the other hand, are more of a technical notion. The goal of the microservices-based architecture is to decompose a system into a set of decoupled yet coherent components. And the thing is, there are different ways to decompose a bounded context into microservices, but not all of them are equally good. Some are more susceptible to changes across the boundaries of the services. For example, as a result of refactoring or changes in the requirements. And when you have to change your boundaries, usually it's very, very painful. Therefore, to minimize those painful changes, we have to be very careful when choosing service boundaries. If only it was that easy. As Udi Dahan said, finding boundaries is really hard. There's no flowchart for that. And this statement has profound implications. Since there is no flowchart, the only way to find the right boundaries is by making some trial and error work yourself. Which means, by definition, there will be mistakes. There is no way around it. So let's acknowledge this and only make mistakes that are easy to fix and try to avoid doing the fatal ones. In my experience, it is much cheaper, safer, and easier to extract a service out of a bigger one than to start with services that are too small and merge them later. Why? Because usually those changes are hard and teams keep delaying those changes, and as time passes by, they mutate into those balls of mud. Therefore, currently we prefer to start with bigger boundaries and decompose them later as more knowledge is acquired about the business. Now, how big should the initial boundaries be? The less you know about the business domains, the wider the initial boundaries are. So for more complex domains, start with bigger boundaries. But for simpler ones, like supporting domains or generic domains, we start decomposing a bit earlier. When we try to decompose to fine-grained services early on, as in the case of Marketing Hub, we ended up with a distributed monolith. On the contrary, the marketing context started up as a monolith, but it was decomposed later on. We extracted campaigns, publishers, events, creative catalog, and again, it's evident even here. The simpler the domain is, the more narrow are its boundaries. Hence, our rule of thumb is start with bigger boundaries and decompose, if needed, of course, as you gain more domain knowledge. So those are the 5 practical advices I wanted to share. Ubiquitous language is not optional. Domain types change. Embrace these changes. Use them to make your design more resilient. Learn the ins and outs of the 4 patterns of modeling business logic. Use CQRS to represent the same data in multiple models, but don't be too dogmatic about the segregation. And bounded contexts are not microservices. Always decompose to bounded contexts, but divide them further to more fine-grained services, microservices, as you gain domain knowledge. And to sum it all up, I want to quickly reiterate our current approach to implementing domain-driven design. We always start with building a ubiquitous language with our domain experts in order to learn as much as possible about the business domain. To protect the language, our initial decomposition strategy follows the linguistic boundaries of the ubiquitous language. In other words, making sure that each term bears only one meaning in its bounded context, and there are no conflicting models inside it. By analyzing the use cases, we identify the business domains in each bounded context and and design the implementation of each domain by following the heuristic that I've shown you earlier. From this design, we deduce the types of business domains at play and verify them with the business. Sometimes this dialogue leads to changes in the business requirements because we were able to provide a new perspective to the product owners. And finally, as more domain knowledge is acquired, we decompose the bounded context further into more fine-grained microservices. But of course, only if there is a good reason for decomposing them. And if we compare our vision of domain-driven design now to the one we started with, I would say that the main difference is that we went from aggregates everywhere to ubiquitous language everywhere. And since I've told you how the story of Internet was started, a few words on how the story ended. About a year ago, we were acquired by our biggest client, one of the leading trading companies in Israel. Of course, I cannot say that our company succeeded only because of domain-driven design, but I can say that we were able to survive despite the fact that we were in what we call in Israel startup mode. What's called startup mode in Israel, in the rest of the world, is called chaos. Constantly changing business requirements, priorities, aggressive timeframes, and a very small R&D team. Almost through all history of our companies, we had 4 developers, including the team leader. So domain-driven design allowed us to tackle the complexities and to keep delivering working software. And that's about it. Thank you. Thank you. We have 8 minutes for questions, if you have any. Yeah.
So did you find any good ways to refactor up and down that ladder of transaction record, connected record, all the way up to event sourcing? Any good refactoring?
Yes. Once we become aware of those possibilities, the refactoring became much easier because the differences between those approaches are much more gradual. From transaction script to active record, you just abstract those data structures, and keep the business logic that manipulates them the same. From active record to domain model, you move the business logic to those aggregates and play with their boundaries. And for event sourcing, it's basically the same aggregates, but you model the changes as a sequence of events. But the boundaries, which are the important thing about aggregates, stay the same. Any more questions?
Yeah, very situation when you have to take snapshots of event source domains, like for every single change, or you are keeping it like for every 20 changes or something like that?
We decided to keep all the changes. We thought about having snapshots, but honestly, the life cycle of a lead is not that big. And we stored our events in DynamoDB table. Yeah. It was cheaper to keep them there.
Yeah, it's obvious, but I'm talking about snapshots as, because if you have, let's say, 50 events and you want to replay all 50 events,
Yeah.
then you rehide with your objects, right? So
Yeah, understand. Yeah, so that's the same logic applies here as well. The life cycle of the lead is, let's say, the biggest aggregate we had about 500 events, and to rehydrate from the events took no time, so why bother?
Were you able to achieve a pure domain model or a side effect-free domain model?
Yeah, yes.
Bit about you went about it.
Yeah, so
I was asking if they ever
yeah, so the question was, did we succeed to achieve a proper domain model?
a side effect-free domain.
Yeah, a side effect-free domain models. Yeah, so for example, in the CRM, when we did the refactoring, we wanted to distill this core domain as much as possible because CRM had a lot of entities in it, and we wanted to distill only the important parts, and the important part was the lead aggregate itself. That's it. All the rest, all different organization units, groups, desks, etc., not interesting. So yeah, so for lead we achieved this side effect free domain model. For leads, for example, in the marketing domain we did it later for campaigns as well.
So how did your story with microservices end up? So
yeah, so the question was, how did our story with microservices end up? We fell in love eventually. It took some time to work on our relationship. It wasn't easy, but eventually it worked. And
is your current system microservice?
Yeah, I would say it's mixed, but the breaking point for us, honestly, I wasn't sold on this name microservices because it's micro, and I couldn't understand what should be micro about it. Lines of code, and then someone said about pizzas used to feed the teams, and we can feed our whole company with 2 pizzas. So are we working on the same monolith? No. The realization that finally dawned on me that service is something that the system does. The outfacing interface, the work it provides for the other components. So for me, currently microservices are about the minimizing this external facing interface. So naively, you can say that, okay, so you have a microservice with only one operation. So it's like the ultimate microservice, but it doesn't work that way because it has to integrate with other microservices. And then you have to expose additional endpoints. It's like what Randy Sharp calls the public door of the service. And those integration points are like a huge backdoor. So it's not really a microservice. And it takes some time to find the balance, how to divide the system such that all the services in it could be called microservices, but once we got to this definition, things got much, much more easier.
Eric Evans once mentioned that when you have a bounded context, you should have a strong boundary.
Yeah.
And it seems that you're forced this by actually having something like a service. But you said obviously that not each bounded context is actually a service or microservice.
Yeah.
So how do you enforce that?
Yeah, so the question is, Eric Evans said that the bounded context should have strong boundaries to protect it from the rest of the system. What I said that not each bounded context is a microservice. It is definitely a service, but it doesn't necessarily answer my definition of a microservice. So definitely a service, it definitely has a strong boundary.
I haven't read the blue book, but there's another book that's not as old called Patterns, Principles, and Practices of Domain-Driven Design, and they talk about modeling bounded context in terms of the invariants based around the business rules of joining. Can you comment in the context of that based on how you did modeling, maybe?
Yeah, so first of all, it's a great book. When we have when we have juniors joining our team, that's the book they have to read, first of all. But regarding this point, the question was to model the Nick Tune's domain-driven design book suggests dividing a system into bounded context following the business requirements and use cases. In our case, we try to do it, but the assumptions we made, for example, at the first version, we had almost always had to change them for the second version. Because for core domains, the business people, they have no clue what they want. No, they have a clue what they want money. They don't know how to achieve it. So they're changing their opinions and they're inventing new features, and they do affect those boundaries. So that's why we decided to keep the boundaries wide, let them stabilize on their ideas, come up with the best solution after a few iterations, and only then to decompose the system.
So you found that hard business rules that are never supposed to change were changing that fluidly that you couldn't model?
Yeah, exactly. So, yeah. So the comment was that the business rules that were not supposed to change actually did change. Any more questions? 1, 2, 3, sold. No more questions. And a shameless plug.